Welcome back, everyone, for our last session presentation for the conference. And if everyone will recall that we have the speed debate, the last thing this afternoon before the closing speaker. That will be, I believe, at 2:25 and is always entertaining. So we encourage you to kind of drill into that. But our last session now is we have Christian Studer and Andras Iklody with their presentation on MISP threat sharing and new features. Now, this is a recorded presentation, but both Christian and Andras will be around at the end to field some questions. So feel free to pose questions throughout and we'll deal with them at the end. So I'll hand it over to Christian and Andras.
Welcome to our MISP status update talk, where we explore what has changed since last year AusCERT in regards to MISP. I'm Christian, and I'm here with Andras. We both work for CIRCL, the Luxembourgish national CERT for the private sector. CIRCL is an organization founded by the Ministry of Economy to build cybersecurity for the Luxembourgish private sector, and among our duties, we are also building various security tools for the community, such as MISP, where we lead the development effort. We also run several sharing communities using MISP for various sectors and trust groups. And as such, we're both the driving force behind the development as well as power user of the tools. The aim of today's presentation is to give a quick introduction into what MISP is, in the first place, for those new to it, and then proceed to go through what has happened around MISP over the past year. We will also take a look at what we are planning in terms of development for the coming time. So let's take a look at what MISP actually does. First, if we had to define what MISP is, the closest description would be a threat information sharing platform, so basically a TIP, with a strong focus on sharing. The software is free and open source. The main purpose of the platform is to collect information sharing from various different sources, which could be the outcome of your own investigations encoded by your analysts, automatically created data by your tooling, information shared by your peers, or obtained via OSINT and vendor feeds. This information is then normalized, enriched, and correlated to get the most of the data you collect in the above mentioned ways. MISP also has a strong focus on collaboration, so you can work with your peers on refining the information. Finally, all of this information is used to automatically feed your protective tools for the purpose of detection, prevention, and analysis. In order to achieve all of the above, we have a list of features that support the entire workflow in many different ways. Just to highlight a few, we have an extensive API that makes integration easy, both on the producing and the consumption side, as well as a host of automatic functionalities that generate insights about the data, such as the correlation engine. MISP's primary focus is the exchange of information, which it achieves via a MISP-to-MISP synchronization system, along with granular data distribution settings, ensuring that your data reaches the all intended recipients and the intended recipients only immediately once it is ready to be shared. Since exchanging information with machines is only half of the story, we also provide a bunch of visualization tools to make understanding and working with the data more easy for analysts, including a graph representation of all data, dashboarding, and various statistics overlays. As for interconnecting MISP with your tools, we offer a bunch of different import and export formats to make the feeding of IDSs, IPSs, SIEMs, host scanners, analysis tools, and firewalls straightforward. So that's basically it for a quick explanation of what MISP is. If you want more details about it, you can have a look at misp/project.org or our GitHub page, or even watch our last year's AusCERT presentation. Now let's take a look at what changed since our last presentation. Some numbers here first in regard to the activity of our development community. We've had 34 releases since last year, spanning a total of almost 4,400 commits, contributed by almost 100 different contributors to the core and libraries directly used by the core. Despite all the hurdles this year, it looks like COVID-19 did in the end not really impact the momentum of our development process. The improvements include a long list of bugs, among others also several security fixes. Since we are building an open source tool for the security community, we're in the lucky position to get a very high number of penetration tests where their outcomes are reported to us. We as a CIRCL take these extremely seriously, and we're quite vocal about anything that might lead to security issues. As such, we request CVEs for any security issue found. Please make sure that you keep your MISP up to date, and if you run MISP, follow our Twitter account to receive updates on when we have security fixes available. Besides fixing bugs, we improved how MISP behaves in general. So expect quite a few improvements. We have also spent quite a bit of time this year to tune and rework the internals to accommodate the rapid increase in user base and data shared in MISP. In general, there has been quite a considerable effort done by the community to encode context libraries in MISP, meaning a host of new vocabularies, knowledge base items, and data models that were encoded. But besides these more general improvements, let's have a look at some of the feature highlights that have dropped over the past year.
So let's have a look at some of the major features and improvements since last year. So one of the main aspects that we were lacking in MISP was the accurate timelining of the various events described in MISP, something that the inclusion of the new timelining feature that has recently been merged has alleviated. Here you can see a sample of the events timelining as presented in MISP. So each of those individual data points there are either attributes or objects, and now we can place them in time on the timeline. Since we put more effort these days into the IOC lifecycle management part of things, it has become more and more important for us to be able to place these IOCs in time. It also allows us to better tell a story about how an incident progressed. So just being able to see the links from before between objects is now also additionally enriched by the timeline where we can see how each of the events followed each other. Instead of just dumping our IOCs and our partners, we now have a system that allows us to basically deal more with the story and tell a story through the shared information directly. And this is mainly due to an increase in capabilities, both on the producing and the consuming side. What it actually means is that organizations that are now producing or enriching data are more likely to contextualize their data well. This is partially because the tooling has improved, and tooling automatically does this now for us when it comes, for example, to attack techniques. A lot of the automatic tools extract this information, include this in the output. But we have also matured in our processes and what we are actually looking for. We have matured as organizations, basically. On the consumption side, we are dealing with richer data, obviously, because richer data is produced. And we're also dealing with more voluminous data due to the increases in the sizes of the communities and the sharing in general. So it has become more and more important to restrict our working data set to a better sub-selected set of our full data set, either to avoid overloading our systems with basically not that useful information, and also to avoid false positives in general. Timelining also has allowed us to see time-based correlations between different events. That means that we can now determine which occurrences happened at the same time as certain other occurrences and draw conclusions from that and find potential links between those things. Another major development was the outcome of mostly our personal interest, or rather, should I say, our personal fears, when it comes to COVID-19 and how it was evolving. We were simply trying to make sense of all the information that we saw online and that we received about how the virus was spreading, how it affected us, how at the time when we were still planning our travels back early in February, how it was affecting our travel engagements. So to track all of this, we tried to modify MISP to make it work for us. So we basically stood up a special COVID-19 MISP community, which we supported by building a whole new dashboarding system for MISP. The idea was to make something that allows us to build widgets rapidly and allow users to basically configure their own dashboards directly from the interface, while fully making use of MISP's internal functionalities, along with the ACL system and so on. The COVID-19 community has turned into a massive success since then, with a large user base sharing information about health-related aspects of the pandemic, cybersecurity threats, as well as misinformation threats. So anything that we're facing during the pandemic, basically. If anyone's interested in joining that community, simply visit the URL on the slide and register for access. Now, obviously, the COVID-19 dashboard widgets were more of a proof of concept in MISP. And since then, we have a wide range of other types of widgets to support different use cases, be it from administrative widgets that allow us to basically sanity check our MISP and monitor the administrative tasks, to sharing trend widgets that basically show us how active our community is, how mature the different organizations are in different types of contextualized data sharing and so on. And also gamification that basically allow us to rank the sharing of organizations. So if communities opt for having that enabled, then you basically have achievements and so on per organization. So here you can see default dashboard of the COVID-19 MISP instance. So when users log in and go to the dashboard, this is what they see. It basically shows the trends derived from the Johns Hopkins dataset. All of these widgets are highly configurable by each user individually. Users can create and configure dashboards to their own liking and save their state. They can also decide to share their configurations with other users of either the instance or outside of the instance by exporting JSON configuration documents. Administrators can also choose to pick a dashboard as the default of the system, meaning that new users logging in will be automatically getting that dashboard pre-configured. As for the development of new widgets, it follows a similar mantra to the modules that we have in MISP, meaning that we try to make it as simple and plug and play as possible, with a wide range of helpers to ease the development. So if you want to get involved with that, have a look on GitHub how the modules work and just get started with it. It's rather straightforward. We've also spent a fair amount of time to rework our initial implementation of our indicator DK system. So mostly to allow for more customization by the individual users. We can now create user-specific rules that are automatically used by their individual API queries, meaning that we can create special tooling user accounts for the various different use cases that all have pre-configured rule sets, ensuring that they all get user-specific subsets of the full data set. So if you have a scene configured to pull data from MISP, you can tune the rules for that specific user to either use the indicator DK system or other metrics to define the data set. We have also opened up the re-evaluation of taxonomy label values to further refine how each vocabulary is treated in the context of the indicator lifecycle management. On a more case-by-case basis, this can be overridden by either the administrator globally for the instance, or by each individual user for their own liking. One of the key elements missing from our calculation before were also the citings provided by the community. These are now factored into the indicator scoring system, meaning that data reported as still being relevant has its DK reset based on the citings.
When an analyst inserts information into MISP, it's very common to start with a set of unstructured indicators. At a later stage, combining attributes into objects starts making more and more sense. However, the effort spent on the process of creating those attributes again within objects will result in analysts deciding to save time and move on, leaving the unstructured data as is. To reduce this workload needed to bring structure to our prior work, we introduced the feature allowing users to easily select a set of attributes and automatically propose suitable object templates depending on the combination of types of the selected attributes. Once the template is set and the proposed change is confirmed by the user, the selected attributes are then merged into an object. Besides MISP itself, we also had a major rework of PyMISP, our Python library suite to support integrations and automation in general. We now require Python 3.6 as a bare minimum, and all of the internals have moved to a more object-oriented approach, including a wide range of helpers to make your life a bit easier when talking to MISP. One of the other uses for PyMISP for us internally is we use it as part of our CI process along with a list of tests that we run on each commit. This has grown substantially, and we have a rather complete coverage of all MISP APIs now via the test suite. Also included now in the testing is the setup and synchronization of multiple MISP instances. So we've been able to catch more potential bugs that would otherwise have made it into the main code base. As part of our duty to run and manage communities, we ran into several hurdles that made our own lives a bit more difficult than we like when it comes to running MISP communities. We have implemented a community support suite of features that to make it easier. User configurations allow us as administrators and also each individual user to manage how MISP behaves for each user individually. Sorry. For example, by configuring alerting rules, dashboards, and so on. We also added a community listing system, so communities can opt in to be listed here if they reach out to us. And they will be listed by default in any new MISP installation. The idea is that we now have a simple process where users can select the communities that they think they ought to have access to and apply to them directly from MISP. The owners of the communities will get an alert email describing all necessary information to enroll the registrant. Then would they choose to allow them into their community. We have also improved our integrations with authentication systems, and also we had an email-based OTP system contributed to MISP. One of the key purposes of MISP is to fit our user workflow by supporting the tools and format they use internally to their daily work. We've been working with vendors to make sure that their subscribers have easy access to their services through MISP, with the list of integrations rapidly growing over the past year. In addition to integrating with specific tools, we've also been working on our various integrations targeting other Exchange formats, including a comprehensive rewrite of our Sticks2 integration.
we have quite a few users of Maltego already that were basically using the integration for MISP before. And thanks to Christophe van de Pas, this has now been greatly reworked and is now available via an official transform in Maltego. So you can use MISP as an additional transform backend for your work in Maltego. We also drive the development of a set of other open source tools in-house at CIRCL, which have received a tighter integration with MISP. So this includes SCALE, our analysis into information needs framework, as well as T4, which is our open source sensor network. So if you're interested in any of those projects, have a look at our GitHub pages. Everything is open source that we do and available, and they're all now tightly integrated to MISP. A long list of new galaxies, taxonomies, and object templates, so basically our context libraries, have also been contributed by various partners and various parties. And one of the most interesting new developments we've seen over the past year, we're basically riding on the massive success of the attack framework from MITRE. We have basically seen a long list of attack-like matrices being encoded as MISP galaxies and added to the system. This means that the ideas and the representation of the framework have been mapped to other domains. For example, in the domain of disinformation by AMET, financial fraud, election interference, GSM-related attacks, and several others. So I highly encourage everyone that is thinking of mapping something, a framework of contextualizing information that includes a kill chain element as well as different techniques to think about reusing the methodology of attack.
With MISP, we have a module system providing autonomous Python modules that can be used to either extend data that is already in MISP or populate your MISP events with some data to import. Those modules have always been very lightweight pieces of code, handling simple queries and returning single MISP attributes to add to an existing event. But at some point, we realized the simple input and output model we used since the beginning of the MISP modules would be blocking us in parsing some more complex queries. So we recently introduced a new type of modules called MISP format modules that are able to return the full spectrum of data and its respective contextualization that MISP supports, while maintaining backwards compatibility by supporting the old format additionally. This allows us to not only capture indicators, but also the context provided by the external services. Let's see the advantage of MISP format modules with an example. The text attribute shown under the CVE value in this screenshot shows the output of the old CVE expansion module, which is a single flat attribute with a description. The new module returns a complex object with additional details such as references, a CVSS score, and other data points extracted additionally. Besides this, modules could also include labels and inter-object relationships whenever they would make sense. Now let's have a look at what we have planned for the future, and keep in mind that nothing is set in stone besides what is basically just around the corner. So for some of the long-term features, priorities, things might shift around. We've talked about our improvements to the MISP module system already, but despite there being a shift in the right direction, we're not happy with them just yet. Expansion modules are currently limited to expanding individual data points. We want to expand this to take into account its context. In MISP terms, this means that we'd like to introduce the expansion of entire events as opposed to single attributes. We also want to expand our import modules to be able to create an entire contextualized events or collections of events rather than just lists of individual indicators. Another hurdle we need to overcome are long-lasting enrichment processes. Think of submitting a sample to a sandbox and retrieving the results, for example. For this to be more convenient, in the future, we plan on providing support for the deferred execution modules via a messaging system. We also want to simplify the obligatory user interaction for dealing with module output. Currently, users need to confirm the results before they're stored. We want to make this step optional for modules where the results are more self-evident. Of course, dealing with uncertain results make this, in many cases, tricky.
One of the features that we've had on our roadmap for now almost half a decade is in the final stages finally, so and almost ready to emerge. For example, this includes the sharing of custom galaxies, meaning that the knowledge base libraries that we have in MISP on all sorts of topics such as threat actor information, attacker techniques, and even attack from MITRE are basically encoded in this system, and these will be opened up to sharing and modifications. So you'll be able to create, modify, and fork and share your own galaxy clusters so that your community may use those to contextualize the data. The distribution system will be similarly granular to what is used elsewhere in MISP. This means that you will be able to keep ownership of the modified and newly created galaxies the same way as you would with events, for example. Another major improvement for the galaxies is being able to relate them to one another. This allows us to also tell a better story basically with our data. For example, being able to attribute data to a threat actor that is known to target a certain sector and having a suspected motivation are now possible with this new system. The feature is already in beta and available, so it is already being tested by a set of organizations, and this is last call basically to have your say. So if you want to influence how this system will finally work in MISP, now is a good time to basically get started with it and give us a sanity check before we actually merge it. So besides having and sharing structured data, which is really great for automation, one of our annoyances with MISP was that we had a hard time expressing just plain text information along with the data. So we're changing this by including the report feature that allows us to basically tell our story in a more unstructured form. What we're going to be using are markdown reports that will travel along with the events and be treated as part of the package. So when we started out with MISP, we were basically dealing with a very tiny set of communities and a tiny set of organizations in our individual communities. So basically from a community management aspect, the exchange was rather lightweight. This has changed over the years drastically. We nowadays have massive communities with deeply branching MISP networks, meaning it's become difficult to have oversight over the different communities and efficiently exchange, for example, information on organizational metadata to build your trust in your community. We have another open source project in the making, which we hope will change this. The tool is called CIRCL and is part of an EU-funded project called Melicertis. The goal is to have trusted CIRCL nodes run by central authorities of the various different communities, providing a trusted library of the organizations, the various different distributions, so sharing groups, as well as encryption keys for their various different communities. So we also want to make this tool instrument and easy interconnectivity between organizations. So if you want to set up connectivity to members of your ISAC, for example, this tool will help you instrument that. As for the key exchange part, it's part of a long-going development in MISP. So those of you that are following the project closely have probably seen some traces of this already. We want to basically provide data signing and the validation of the signatures of data within your communities. An early alpha version of the tool is already available on GitHub, so have a look and get involved in the development. We're also planning on moving MISP to a more modern stack, leaving behind the by now rather dated framework stack that we're on. Cerebret, the tool mentioned just before, acts as a testbed for us. So it shares a lot of the internals with MISP, and we use it to gradually also port subsystems and components of MISP over to the new stack. So the two projects will start sharing more and more code, and more of the code will be unified into something similar so that we can port it over once we're ready to move to the new stack. So to sum it all up, there are a lot of exciting things happening. And as you can see, we're chasing down quite a few different paths of development and improvements from MISP. But sadly, we're hindered by days only having 24 hours. So if you want to help us, there are a lot of ways to get involved. Be it from sanity checking what we do, helping us with the development directly if you have development capabilities that you could divert, or by supporting us financially. So just reach out to us. Prioritization is super hard. So one of the most simple but also helpful ways to support us is to let us know what you think we should focus on. We rely on such community feedback to hopefully make better decisions. So this is pretty much it from us. If you have any questions or just want to get in touch with us, here are some of our availabilities. So thank you all for tuning in. And if you have any questions, we're around. So just ask away and we'll try to answer them the best we can. So thank you all.
Here we go. We have Andras. So I'm just reading from the Q&A tab. There's my first question was, how is this product different, better than MITRE's attack framework?
Oops, to quickly answer that. Yeah, basically, so MITRE attack framework is a framework that we also use to contextualize data. But MISP itself is more like a tip. So basically, it's the tool itself that allows you to create the data that you would also place within the attack framework. So I hope that answers it.
Another question was, is there an integration for Splunk that you would recommend?
Yeah, so in the Splunk App Store, there's a tool called MISP42 Splunk. So I think that's the most complete integration that we have out there. So it should be in the official Splunk App Store. So just grab that and you're good to go.
And Alan has a question, where can I find more details on Cerebrate?
That's a good question. I didn't put the URL in there. So the URL is, or actually, if you could just go to GitHub, there's an organization called Cerebrate Project, so Cerebrate-project. So just go there and you will find the first version that was released like a month ago. It's early alpha, so early days, but development's ongoing. So if you have any ideas or basically feedback on that, would be much obliged.
Do you think we might be able to get you to post a URL to that in the chat conversation?
Yeah, that would be great. Indeed, that's a good idea.
Maybe after
yeah, I'll do that right after.
Yeah, that'd be great. Well, if there's no other questions, we can break now for afternoon tea. And again, yeah, we look forward to seeing you all at the speed debate at 2:25. Thanks, everyone.